A-level specification, Mathematics A for OCR. So today we're starting 1.02, Algebra and Functions. We're going to be going through indices today and all their different rules. Now first of all, what is an indice? Well, an indice is a number of this form here, x to the a, where x is the base and a is the power. You're going to hear me saying base and power a lot. All it means is the number below, x, is the base, and the number here on top is the power. For example, if we have 3 to the power of 2, 3 is the base, a is the power, 2 is the power, sorry. Now, on the spec, it says we have to go through, these are not official names by the way, it's just names I've given them to make it easier to remember. The multiplication law, division law, bracket law, rational law, surd law, and the power of 0 law. We'll go through the multiplication law as well. So when you multiply two indices with the same base, you just add their powers. So let's say we have one which is x to the a, and we multiply it by x to the b. We'll then get x to the a plus b. Next up, we have the division law, where if we divide two indices with the same base, then the one on the left, you take away the power of the one on the right from it. So if we have x to the a divided by x to the b, we get x to the a minus b. Next up is the bracket law, which if we have a indice, put it to a power, we just multiply the two powers together. So if we have x to the a in brackets to the power of b, that'll just be x to the power of a times b. Next is the rational law, where we have x to the, well, we have a base to a minus power. All we have to do is take 1 over that power. X to the mn. X to the m over n is the surd law. So if we have x to the m over n, we essentially take the root of that bottom power, and the top power remains the same. Last but not least, we have the power of 0. So any base to the power of 0 will always give 1. Let's go through some examples. So first up, we have the multiplication law. And we'll go through some examples like 3 to the 4 times 3 to the 7. Well, the rule says we have to add the powers. A times b will give a plus b. Well, x to the a times x to the b will give that. So these two have the same bottom power, so we can actually multiply them together using our multiplication law. And we'll get 4 plus 7 at the top, which will give 3 to the 11. Next up, if you've got that into your head and you understand it, you can go to the next one, which is 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2 times 2 to the 6. I've just done it one by one. So 2 times 2 to the power of 2 times 2 to the power of 2 will give 2 to the 4. These two will now multiply together. So 2 to the 2 times 2 to the 4 will give 2 to the 6. 2 to the 6 times 2 to the 6 is 2 to the 12. Last but not least, we have a bit of a higher power, just to show that, you know, it's not just small numbers, so you can have bigger numbers. If you put this in a calculator, I doubt you'll get less than 3 digits. So 5 to the 5 times 5 to the 10, just give 5 to the 15. Now this lets you know why we actually use indices. It just makes it quicker to multiply big numbers which we know have lower base powers. Now examples of b, which is the division law. So just to recap, the division law says if we have x to the a divided by x to the b, we just minus b from a to get the new power. So 3 to the 10 divided by 3 to the 5, we minus the 2 powers, and we get 3 to the 10 minus 5, which is 3 to the 5. Next up, we're going to do it again, but this time we have 3 to the 5 on the outside as well. So 3 to the 10 divided by 3 to the 5. Over here, we know from a that is 3 to the 5. But just to, make it easier to visualize, I haven't simplified it here. So you have 3 to the 10 minus 5 divided by 3 to the 5. You'll get then 3 to the 10 minus 5 minus 5, which will simplify to 3 to the 0, which will then give 1 by the power of 0 law. Last but not least, we have 3 to the 5 times 3 to the 5 divided by 3 to the 2 times 3 to the 6 divided by 3 to the 3. Now, what I wanted to illustrate by this example is a quicker way to, if you just have the multiplication and division law together, you could just add whatever is multiplied and minus whatever is divided, just to do it a little bit more efficient. So we have times 5, which translates to plus 5 when you have a base of 3. Well, any base of that matter, but since they have matching bases, we can actually do this. Divided by 3 to the 2, you'll get a minus 2 over here. Times by 3 to the 6, you get a plus 6 over here. Divided by 3 to the 3, you'll get minus 3 over here. So if we put all the positive numbers together and all the negative numbers together, we get 5 plus 5 plus 6, which is 16, minus 2 and minus 3, which is minus 5. That'll simplify to 3 to the 11. Now we got the bracket law. Again, these are names just I've given them. These might not be official names, but anyhow, it's just something to make it easier to remember. So here we've got 4 to the 4 in brackets to the power of 3. What does the law say? It says we have to multiply them together. So 4 times 3 is what we end up with. So 4 times 3 is 4 to the 12. Here, so we know by BODMAS or BIDMAS that we have to, so this is for part B, that we have to resolve the brackets first before we can, what's inside the brackets before we can move on. So 4 to the 2 times 4 to the 3, it's 4 to the 2 plus 3, which is 4 to the 5. We've still got the squared on the outside. We just multiply that together to end up with 4 to the power of 10. For part C, we got 4 to the 2 times 4 to the 4 divided by 4 to the 3, which is just like 4 to the 6 divided by 4 to the 3, which will end up with 4 to the 6 minus 3. Don't forget the cubed, so you just have to multiply 3 by 3 and you'll end up with 4 to the 9. Examples of D. So D is the rational law, which basically means just take the power inverse of the number you have to simplify a little bit. So you have 3 to the 4 times 3 to the minus 2. This will simplify to 3 to the 4 over 3 to the 2. This line is just to separate A and B. And this is the same as dividing. So you know that you just have to minus it by the division law. So 3 to the 4 minus 2 is 3 squared. The next one we have 5 to the 3 times 5 to the 2 divided by 5, which equals 5 to the 5 over 5, which equals 5 to the 5 minus 5 to the minus 1, which is just 5 to the 4. For part C, we have 7 to the power of 10 times 7 to the power of 4 divided by 7 to the 16. Now, 7 to the power of 10 times 7 to the power of 4 using the multiplication law is 7 to the 14. Dividing it by 7 to the 16, this happens here. We'll end up with 7 to the minus 2. To express this as a rational number, you just do 1 over 7 to the 2. Next, we've got the power of 0 law and the surd law. We'll go through the surd law first. So this says having x to the power of b over a is the same thing as having a root a and then doing x to the b. We've got an example right here to make it easier. So if you have 9 to the 10 times 9 to the 8.5 over 9 to the 16, that'll simplify to 9 to the power of 18.5 because 10 plus 8.5 is 18.5 over 9 to the 16. So 9 to the 18.5 times 9 to the 16, well, that should be a minus, is 9 to the power of 2.5. 2.5 is the same as 5 over 2. Using then the surd law, you get a root 2, and then you get 9 to the 5 in here. So the square root of 9 is 3. You'll just end up with 3 to the 5. Next one's a little bit simpler, but using a bigger root. So 27 to the power of 4 over 3. You can re-express that as a cube root of 27 to the 4. Then the cube root of 27, so 3 times 3 times 3 is 27. So we know that the cube root is just 3. You'll end up with 3 to the 4. Now, examples of the power of 0 law. Well, we had some before, but what we essentially want is a base to the power of 0, and any base to the power of 0 as well. So, here we've got 3 to the power of 3 times 3 to the power of 6 over 3 to the 9. By the multiplication law, these two add their powers. Then by the division law, you have 3 to the 9 divided by 3 to the 9, which end you up with 3 to the 9 minus 9, which is 3 to the 0, which is just 1. Here you've got a bit more of a complicated example. You've got to use the bracket law twice. This one here is not even a law, it's just, general mathematics knowledge. So, 3 to the 3, in brackets, to the power of 3, in brackets, to the power of 3. So we know by the bracket law that you have to multiply the two powers, and you'll get 3 times 3 here. And you've got to do it again, and you'll get 3 to the 9 times 3, which will end you up with 3 to the 27. Regarding the denominator, all I've done is do 3 to the power of 3, which we know is 27. Then I'll brought that up using the rational law. Then all I've done is simplify it using the multiplication law. So 3 to the 27 minus 27 is 3 to the 0, which will just end you up with 1. There you have it. We've gone through all the indices laws, and tomorrow we'll get cracking with part B, which is surds. If you like the video, like, comment and subscribe for more videos. If you've got any suggestions or any requests, please feel free to put them in the comments.